This example starts with a cyanohydrin as the starting material. The aldehyde that this cyanohydrin is related to has this structure here. And the side product from this is a hydrogen cyanide molecule. And if we're mapping to make sure this is balanced, here's the hydrogen and the cyano group that become this hydrogen and this cyano group in terms of balance. And the remainder, you can see the oxygen and all the carbons are in the aldehyde. We don't need any other stoichiometric reactant here. We do need a base. And the simplest version of this reaction is going to be the one in which the base matches the leaving group. So let's go ahead and look at that version. So here's our starting structure. Our cyanide ion as a base can start by deprotonating at this site. Let's not flip things around unnecessarily. This strong reactive site that we've generated, the alkoxide ion, is in the right position to now kick out a cyanide ion as a leaving group. Cyanide is a poor leaving group, but we have a strong reactive site available to kick it out. And the energy benefit that helps there is we're making a carbonyl pi bond. And the side product from this step is cyanide. And so if we're looking at how this is considered a catalytic reaction, we can say we used a cyanide and we made a cyanide. And if we're looking at our balanced equation and we want to explain that HCN molecule, we have to notice that this first step wasn't balanced. We can put in the HCN here as the side product from that step. We can say here's the HCN in the box above where we were balancing it, and here's the HCN being formed during the reaction. In the reverse direction, here's our aldehyde starting material. A cyanide ion would act as the nucleophile. That breaks the carbonyl pi bond and gives us an oxygen minus charge and makes the new carbon-carbon bond. We have a stoichiometric amount of HCN that needs to be used in this direction, and so that will be our acid source, a pretty weak acid. And it will protonate to give the cyanohydrin product. And the side product from that step, the conjugate base of the acid that I used, is this cyanide ion. So to do our mapping, we used a cyanide and we regenerated a cyanide, so that is a catalytic base. We're going to write down here that in this example we used a cyanide as the catalytic base. And we also used a stoichiometric amount of the HCN, so the same yellow color coding as before. We've got an HCN molecule on the right side of this equation. Here it is being used up as we travel from right to left.